Okay, let's go. I'm jumping into top Microsoft questions. Previously it was top 10 Google questions. Now going to be a top 10 from Microsoft. Now LRU cache list recently used cache. So we got the elements of restricted capacity and to implement the get and put method with a constant time complexity. So how it works is that the method has been called, the put has been called with the 1 and 1, so this is a key value pair. I'm going to go for another put like 2 and 2, this is normal key value pairs, and then we are touching the 1 here through the 1 and 1 key value pair from the keys, so we need to get the value from the key of 1, so we're going to be returning a 1 here because this is a 1. And now this is recently used, so we need to go into the front of the cache, and that goes to the end of the cache. And since the capacity was 2, then this is most recently used. And then when we're putting the 3, then the 2 is going to vanish from our cache because 1 just overrided it, right? Okay, and how are we gonna do it? It's a pretty tricky. So first of all, we want to create some kind of a hash map. So get the constant time complexity when it goes to getting the element. So first of all, we need to some kind of a hash map by the keys. And then we need to some kind of mechanism that will put the elements in a good order. So when it comes to putting elements in a good order, the good solution is to use the doubly linked list, a doubly linked nodes. So how it works is that when we get the node here, I want to put 1, 2, that's a put, then we're gonna get 1, and then put 3, right? Then we're going to put 1 here, and that's a node, double linked list node, and this node going to be directing to the head. This is a head, and okay, and this is a tail. Okay, and when we're going to put another node, and we're going to add this head, we're going to add it to this next to here to the next one. Okay, so that's 2. Nope, nope, that's not the order. That they're going to be 2. They're going to be 2. They're going to be 1, and going to be tail. Okay. And when we are going to get the 1 from this array, so that there is a pointers, so we got a hash map here with the elements of 1. This is a1 and 2. This is a hash map, so we got the keys here, and this key is pointing to that node. Oh, what a ugly arrow. And this key is pointing to that node, right? So when we're pointing to that node, we know the surroundings of that node, like the previous element and the next element. And now when we're going to get this element, and what we're going to do is we're going to move this element to in front of the head element. So what we're going to be handle this, we are going to replace that one with that one, like, okay. So maybe more clearly, we're going to remove that one, insert element here, and add the 2 here, so that we get closer to the head element, right? And if we're going to put that 3 here, so that's also that is also going to be removed. The pointings have changed. Okay. And when we're going to add the element of 3, so we know that our capacity is 2 here, maximum capacity is 2. So when we're going to add the 3 here, then we're going to add the element, want to increment the element to the count of our capacity, and then we're going to notice that this is more than our capacity, so we're going to remove the element from here, from the last one. Okay. We're going to push this 3 in front of the head because this is the most recently used, so that would be that one. And just move this one that was recently used, secondly recently used, here. Okay, that's going to be quite a long implementation, then keep it up. Okay, let's try to implement that. So first of all, we want to introduce some kind of data structure. So public class the length node, that is going to be int key, node have a key and int value, and the length node of next and the length node of previous. Okay, let's enter the constructors. The length node of int k, int v, and key is equal to k. Okay, and v value is equal to v, and also the length node empty constructor. So we're going to have easier to create our initial head and tail elements. Okay, so what we're going to do, so first of all, we want to introduce some constants. So let's say capacity is equal to 0, let's say, for now. Int counter is equal to 0 for now. Hash map of integer, that's our cache. The length node, that's going to be a cache new hash map of the integer, and the length node. Okay, and that's we're almost done. Now into another constants like our head and tail. We always want to have a grasp of it. So the length node is equal to head and tail. Okay, now we're going to introduce the variables. So capacity is equal to capacity. This counter is equal to 0, so it's good. And the head is equal to new the length node, and tail is equal to new length node, double length node, and head dot next is equal to tail, and tail dot previous is equal to head. Okay, so we got it. What we're going to do now, when we're getting the element, now we want to get the element from the cache first of all. So var node is equal to cache dot get by the key element. Okay, and now we need to check if the node is equal to null. If it is, then we're gonna return -1. That's the requirements of the exercise. So we're gonna return -1, and there are no elements. If there are elements, then for sure we need to remove element. Excuse me for a moment. So for sure we need to move this element to the head. So this is a head move to head, and there are going to be a node as we presented, and return the node dot return node dot value. Okay, so let's implement move to head functionality after that one. Okay, so private void move to head the length node of node. Okay, so how we are going to do it? how we are going to move this node to the head. So first of all, we need to have some kind of a so we need to like connect this node.next with the head.next. Yep, and node.previous is equal to head. So now the next element from this node is pointing to the next element of the head node. So we're just injecting it in front of between the head and the next element of the head. So this is pointing to the head, and now the previous element is a head. Okay, so that's the first element. Now we need to grasp the second element, logic. So now the head.next.previous. So the next element that was previously a first element, we need to set the previous element from that element to the node. And head.next needs to be a node, right? So we got the method from the move to head, and that moves to the head. Okay, that's good. And that's it for that method. The Gantt is finished, and now we're going to go through the put method. So first of all, when we're going to have a put, we want to also want to have the var node is equal to cache.get of key. If we got that key, if node is equal to null, if we don't have that key, then we're going to do something and return. If we have that key, then we're going to that value is equal to value, update that value, and to move to the head. Move to head. That node. Okay. As far as I'm concerned, now we need to what we're going to do here. So first of all, when we have a null value as a node, we want to iterate so that we cannot exceed the capacity. So we need to like create that node. We don't have it first of all, so we need to new node, create that node with a new linked node, doubly linked node, key and value. So we've created that node. We need to increase the counter, and now we want to check if the counter have exceeded. So counter is greater than the capacity. And before we do it, so now it's the time that because we are putting the element in front of the cache. So it's, for sure, this is least recently used element. So we need to push it to the cache. So cache that put the key and new node. So we have added it. And now, if we exceed the capacity, now we need to remove the last element, the tail element. So let's go with it. Remove from tail. And that's going to be it, right? Oh, and counter minus. Because we have exceeded it, then we're going to land on the normal limited version. So capacity would be here after this will be capacity. Okay. So let's implement a remove from tail. Remove from tail, private void, remove from tail. So first of all, what we're going to do is remove. So first of all, we want to have some kind of a grasp of a previous element. So a node is equal to tail that previous element, and now we want to remove that element. Remove node from tail and the node. So let's implement the remove method. Whoop. Private void remove, and that will be the linked node of node. And we're going to remove that element. So during the removal of the element, we need to be careful not to not to remove too much, right? So first of all, let's go and handle the previous element. So node.prev and var next element. So node.next. We got the next element and the previous element. Now we need to connect this next element and previous element. So the previous element dot next is equal to next, and the next dot prev is equal to next dot prev is equal to previous element. So that is removing the element. So we just we just took the previous element and the next element and connect the previous and the last one, so that initial like the final result is that the middle element just doesn't exist right now. Okay. So now we have we have removed from the tail, we are returning, and now I just forgot the element. We need to push it in front of our linked list, so we need to add a node here with the new node, so that we know that this is in front of our queue, like a queue linked list. So let's add that method, private void add node with the linked node. And now when adding a node, we just need to, we haven't implemented it right. We just need to add a node. So we just need to add a node. So we are adding a node here. So let's create a method. Let's move that method here. That's adding a method, adding a node to the head. Right? We are adding a method to the head here. Okay, and we want to have add the node here with the node, and we need to, when we're moving to the head, we need to remove the node of node, and we are removing the node and then moving it to the head, so adding a node. And when we are going to add the node simply without removing it, without moving it to the head, we're just adding it just like that. Okay. And we also need to remove the element from the cache. So we get remove from tail. We need to remove the element from the cache. So cache dot remove and the node dot key. Okay, let's try to run it. It seems like it's working. Everything is correct, faster than 0 people. Okay. So it seems like it's working. So let's go through it one more time. So first of all, we need to initialize the capacity and the head and a tail here. The head and tail is a doubly linked node, which is connected to the previous one and the next one. And we can have a handle on that connection, the surroundings, and this is also having the key and a value pair. Now this head and tail doesn't have a value, so we can just mark that this is a head and this is a tail. So nothing is special is going to go here. And now we get the get method, so we're going to go to get it from the cache, and if that does not exist in the cache, then we're returning -1. If it exists, then we're moving the element to the head, because this is least recently used. So what we're going to do when we remove it, when we're moving it, then we're going to remove the node, because this is the last element, so we need to remove it. Maybe not last element, but some kind of element in this double linked list. So we are removing that element here, and we are pushing the node in front of the head. Okay, so that's it for here, and we're returning the value. Okay, so putting element, now we're going to also get it from the cache, and if it is in a cache, If that does not run, then it means that we have that value, and we can just update it and move it to the front. And if we don't have that value, we're going to create a new node, because that doesn't exist. Put it into the cache and add the node in front of the head. When we're adding it in front of the head, we need to keep track of the hour capacity. So if the capacity is overflowed, has overflown, then we are removing the element from the tail and reverting the counter to the capacity size. Okay, that's going to be it. That's pretty long and pretty convoluted, probably, explanation, but I hope you like it. If you like it, and like and subscribe. Yeah, bye bye.